Okay, hello everyone, and this is my channel Peters. So today we're talking about the compulsory physics about the matters we're talking about the microscopic structure of the atoms. Okay, so and this topic will start from and we know that everything is based on the atoms. Atoms can compose and can get together and models and lots of maybe the liquids, the gas, the statics. So, however, it's really that the atom is the minus unix in the world actually is not. Also, we start to talking about of these ones, and in the 80s, 97s, there's a man we call Thomson. And Thomson actually he is a British and he proposed that he come down experiments and he find out that there is an electrons, and we call this is the casserole. This experiment is the casserole experiment. So this experiment actually give us two things. That the first is that the rays actually is the particles, and actually here is a negative. So really important in the lab days. So when we finish out there, we start to thinking that if the atom actually, so if the atom actually is not the minus units in the world, maybe we need a new we need a new model for all of us, right? So the Thomson proposed some theory about this. He thinks that maybe he is just we can use we keep the models of the spheres, and the sphere actually there's lots of the sphere in the models, and just like these ones. So this model we call the prime building models. That's cool. So over here this is what we call it. We think that it is a prompt. So and the prompt is actually the grab seat, right? And over here's the grab the over here's the grabbed jelly. It is a jelly. So this is a positive, and the prompt actually is the negative. So the positives and the negative charge will be mixed together, and we will get the zeros. Okay, so this is great. So in the 1897s, the Thomson told us these ones. Okay, so however, these models should be proved by the experience. So, Thomson students we call the Roosevelt. Actually, the 1904, the Roosevelt, he is the chair. He is very famous because of her studies. His studies. So what kind of study that Roosevelt did? Actually, the Roosevelt he is a radiation specialist. So actually, the radiation in the lab areas, lots of people and lots of scientists really focus on the study of the radiation, and we didn't know what will happen for the radiation, and didn't know the harmfuls of the radiation, the harms of the radiation. So Roosevelt do lots of things about the ionization. So if he is the person who he is the first person to split alpha, beta, and gamma rate in the 1904s, and he also get a Nobel Prize and get a chemistry Nobel Prize for his for his for the honors. And after 1904s, and the Roosevelt start to focus on the topic of the atoms. So actually, in the 1909s, the Roosevelt start to use the bombers, use something to bomb. You use the alpha particles beams to bomber something instead. So in the 1909, that the Roosevelt used the alpha particles. We use the alpha beam, and the alpha beam to bomb the four AU fold experiment. And this experiment actually finally pushed the Roosevelt's propose the news models. The news models we call the planetary models. Okay, so actually, when the times after the decades research and Roosevelt start to dictate these kinds of atoms in the 1990s, one day he proposed to use in the 1990s he used the alpha particles or we call it alpha beams to bomb the nitrogen of the nucleus of the nitrogens. So he finally thinks that there must be a new models. So the new model just like this ones. So here is and here this is the electron. The electron will be circle around, and in the center maybe the center is the positive nucleus. So the positive nucleus may be the proton. We call this is the proton, and the electron will be circles around the protons. So this is we call the planetary models of these ones. However, you want to try to know more about the scaling experiments. This is the elective course when you are all of you on the high school in third years. So we just skip over this one. Okay, so in the 1990 our beings bombarded with the nucleus, the nitrogens, everything got things. We got the new models. So after the 1932s, and a man called Chadwick. And the Chadwick start to use the neutrons. How to get the neutrons? The Chadwick actually also use the alpha beams, and the alpha beams to bomb another nucleus. We call it P. Okay, so alpha being bombed with a B and a BE, and finally he got a new subparticles we call the neutrons. And the neutron actually he doesn't have any charge, so he maintain no charges and no electricities. So this is no electricities. That's great. So in the 1932s. So after these things in 1932s, and finally the people start to thinking that we cannot just use the atoms to symbolize, to represent, to stand for the old matters. So we got have have a new way to help us to know label all these things. So a man who calls the Heisenberg. So the Heisenberg in the same years of the 1932s, the Heisenberg proposed what we call the element symbols. So let me take some examples so how all of you can use the element symbol to stand for it. For example, if we got an element called the carbon, and we know that the carbon actually if you know the pyramid element period tables, the carbon 6 and 7 and 12, actually the 6 is the 6, which means is the electron numbers, and the 12 actually is the atomics mass, right? So this is the mass. So use this kind of symbol can help us know the whole structure of the carbon. So we know that the structure will be, the electron will be, E will be 6, and the E plus P is 12, and also the P is 6. Okay, so we can get all of these ones. So we take another for examples that then N. So this is the electrons, and here is the mass. The mass is 14. So we can get the E is 7, and the mass and the proton is the 7th. And also we can know the mass E plus P is 14. So this we call the element symbol. So this method is proposed by the Heisenberg in the 1932s. So all these things maybe let us know the atom is not the smallest units in the world. However, if there any thing is maybe more minors, so actually yes. So in the 90s, actually after the World War II, in the 1964, Americans, we call them the government. A government proposed some quark theory, and the quark theory actually is be testified is right. So he thinks that quark actually is much smaller than the atoms, and much smaller than the neutron, protons, and electrons. So electron is really small that. However, the government just proposed the quark theory. He only proposed that there are 3 quarks, but actually that finally the scientists found out that the quarks have 6 quarks in the world. So all 6 quarks, including the top quark, bottom quark, charm quark, singularity quark, and the up quark and the down quark. Okay, so all these things is the 6 quark. And also there's some scientists propose that there's another models we call the elementary models. So the elementary model including we call the elementary particle models. So we can all take this elementary model and then the subparticle. So the subparticle actually means that it is not the it is the smaller than the others. Okay, so if something so if the particle is subparticles, maybe means that it actually is the smaller than others. So these models, so the elementary models show us that include the 6 quarks and plus 1 electrons. So all these things, actually we call the elementary particles models. Okay, so this is a Gell-Mann set, and the scientists use that the cyclotron experiment to help us use the different particles to bump together and get a smaller particles. So these things, this is really important. Cyclotron is kind of acceleration to help to accelerating the particle into the in nearly light speed, and help the particle can bump together, and finally will happen the mass energy conservation, and finally get the new particles. So this is really cool. This is really cool experiments. So which of you, if you have talent or interesting in the particle physics, so you can just focus on what today is really cool. Okay, so today's I finished talking about the topic about the subparticles of the subparticle of the matters. So we start from the Thomson, Roosevelt, and Chadwick, and finally talking about the Gell-Mann series, right? So all these things can help all of you to construct the concept of the physics in the particle physics. So see you next time. Okay, bye bye.